Hello, my lovelies. We've learned about circumference, area of circles, composite figures. We even learned about surface area. So remember that surface area is the sum of the area of all surfaces of a three-dimensional figure. And specifically in 7th grade, we focus on surface areas of prisms. So those prisms are those three-dimensional figures with two parallel polygon bases. Okay, so I have some area formulas here to remind us. The only thing I want you to know is a circle is not a polygon. So we are not finding the surface area of cylinders, okay? But we are finding them of trapezoidal prisms, parallelogram prisms, rectangular prisms. We would just call the square type a rectangular prism, a triangular prism, not cylinders, but that formula is just there. So our steps for surface area. Ooh. Identify each face of the prism. Solve for the area of each face, only including those not covered. So remember, if they get stacked or something like that, we don't count that part. Then combine all areas. So this one's a little more scaffolded, and it's got that rectangular prism right there with boxes. The next one with my triangular prism won't be as scaffolded. But here, I'm looking at this, and I've got 1, 2, 3. Why is this not drawing? 1, 2, 3, 4, 5. So this is 5 by 1, 2, 3, tall, and then this back one is, I'm going to count down here. That's the more logical place to put that number. 1, 2, 3. Ooh, so it's actually really similar. So it's 3 by 5 by 3. So the front, okay, I'm just looking at the front. I'm using still those formulas for area of a rectangle. So that front, I've got, 3 times 5, which is 15. And I don't know the units here, so I would just put units squared. Then the back, guess what? Rectangular prisms, most prisms, they're going to have the same front, back, top, bottom, side, side. Triangular prisms are going to get a little funkier though, and trapezoidal prisms. But the back is also 15 units squared. Okay, then the top, all right? And if I need to erase it, you guys did a lot of these on Desmos, I can. And then I can get into, okay, well, so the top is right here. This measurement is the same as this. So, okay, that's 3. And then this measurement is the same as this measurement. Sweet. So it's 5 by 3 again. Okay. If it'll write 5 by 3, which gives me 15. So that means the bottom is also 15. So now I'm looking at the right side. And again, I'm just erasing. Oh, I didn't mean to erase the numbers. Oops. I know still that that's 5 and that's 3. But now I'm looking at the right side. Okay. It's 3 by, this is the same as this length. So 3 by 3. So that's 9 units squared. And that means that the left side is also 9 units squared. Okay, that's surface area of a rectangular prism. But then I have to combine it all, right? So I'm kind of doing this in my head. I know that 15 plus 15 is 30. So 15 plus 15 is another 30. So 30 plus 30 plus, what's 9 plus 9? 18. And that's just a little easier for me to manage. Okay, 0 plus 0 plus 8. 3 plus 3 is 6. 6 plus 1 is 5. 6 plus 1 is not 5, Miss Dolier. 6 plus 1 is 7. So that's 78 square units, okay? Units squared. Same thing, we just tend to freehand it like this, but for words we usually will say square units. So that's a rectangular prism. Then right here, I have this triangular prism. It would be the same with a trapezoidal prism, but a different, I wouldn't do triangle formula, I would do trapezoidal formula. So notice here with these faces, I have a front, I have a back, I don't have a top, but I have a rectangular bottom, then I have a right, then I have a left. Okay, that's a lot of drawing. So I want to erase that all because it's kind of confusing me right now. But that's why on your list there, it doesn't say top. So I'm starting with the front and the back, which are triangles. So remember that the formula for the area of a triangle is base times height divided by 2. Not a rectangle, just a triangle. So here, the base is 6, the height is 4. So I'm doing 6 times 4, come on, divided by 2. Well, 6 times 4 is 24. 24 divided by 2 is 12. So this one, my front is 12 centimeters squared, which means my back is also 12 centimeters squared. And then guess what? The rest of these, they're rectangles. So it's almost like the rectangular prism. I'm going to look at the bottom because be careful that you're not assuming that all these rectangles are the same. Sometimes 1 or 2 of them are the same. Sometimes all 3 of them are different. Okay, but I see that this is 6 by 12. So 6 times 12 equals 6 times 6 is 66. 66 plus 6 is 72. 72 centimeters squared. Then, so I did the bottom. Now I'm going to do the right. Okay, this length. That length is important by this length. Come on. Oh, they didn't tell it to me on that side, but they did tell it to me there. So it's 5 by 12. And I know that one. That one's 60 then. 60 centimeters squared. Okay, sometimes the right and the left are the exact same. Sometimes they're not. So double check it every time. So this is the left side. It is 5 there. And then guess what? It is going to be 12. But double check it. Sometimes that length right there is not the same as this length. So 5 by 12 again. Oh, I guess I didn't have to write it out. I could have just put 60. All right, and then I don't have a desire to add those in my head, so I'm using my calculator, and you guys can use those calculators on Desmos, on your phone, whatever works easiest for you. So I've got 12 plus 72 plus 60 plus 60 equals 216 centimeters squared. That's the surface area of every single surface. But let me do it just one more time because sometimes I make mistakes. So 12 plus 12 plus 60 plus 60 plus 72 equals 216. So I feel really confident on that. Okay, so rectangular, triangular prism. Sometimes we have both. So this is where that step that said solve for the area of each face, only including those not covered. So think about this shape here. If this is a milk carton, there is nothing blocking right here for the milk to come out the spot, right? That would be weird. So that doesn't exist. So I'm only looking at the surfaces that are on the outside. Like if I held this figure and spun it around, what I would see, okay? So we're going to start with the rectangular prism, just because it's a little easier for me to see those sides. So I'm going to start with the front. Okay, that's 4 by, right there, 12. So I'm putting F for front, 4 by 12. What does that equal? 48? Yeah, that's 48. So guess what? That means the back is also 48. Okay. The top, I don't count the top because the top is right here. That doesn't exist in a milk carton. It's literally not there. So I'm not doing the top, but I am doing the bottom. The bottom exists or else everything would fall out. So I'm going to put BA up there for back and BO for bottom. That's 4 by 4. So 4 by 4, which is 16. And I'm not writing the letters because I want to get through this problem because I know it takes a little bit. All right, so I've done the front, I've done the back, I've done the not top, I've done the bottom. Now I need to do my side, my right and left. So right, okay, that's 4 by 12. Ooh, so the front was the same. Oh yeah, because these two measurements are the same. 4 by 12, which is 48. And for a rectangular prism, the left and right are the same. So I'm going to put that 48. And now I want my total. Okay, so I've got 48 plus 48 plus 48 plus 48 plus 16. So there's 4 48s in there. I'm going to multiply those. I don't feel like adding those again. So 48 times 4 plus 16 is 208. Okay, and hopefully I'm not making any mistakes. I am a silly goose, you know this, and I make mistakes. So if I'm making one, you can send me a message later and tell me about it. Okay, so I've worked on that rectangular prism. Now I need that triangular prism. I've got a front, I've got a back. I don't have a top. It literally doesn't exist. It's not physically there. And I don't have a bottom because this piece doesn't exist. It is not in existence. So I don't have a bottom. All right, we got that triangular prism. Sorry, I had to pause for a second, so I don't remember exactly where I left off. But we've got that triangular prism. It's got a front, it's got a back. Remember, it doesn't have a top, and it doesn't have a bottom. Doesn't exist. Then it's got a right and a left. So this triangular prism is actually a little less work. So we're going to start with the front, okay, that triangle. So we know triangles are base times height divided by 2. So there is the height. There is the base. So that base is actually 4. So we've got 2 times 4 divided by 2. Oh, hey, multiplying by 2 and dividing by 2 are just inverse operations. They're going to undo themselves and make a 1, but we'll still show it out. 4 times 2 is 8. 8 divided by 2 is 4. So look how those could have simplified to 1. All right, so the front is 4, sorry. The back is also 4. There is not a top. There is not a bottom. So now we're looking at the right and left. 2.8. So sticking, I'm going to do the right first. So I see that that's 2.8, and this part will be, I go down. Okay, will be 4. So I'm doing 4 times 2.8. I don't know that off the top of my head. I'm going to use my calculator. I probably could have done it. 11.2. Okay, and one thing I've told you is don't assume that the left is the exact same. But one thing I want to remind us is that this is a milk carton here. And notice how at the bottom, it's 4 by 4. So it's the same there. And think about any milk carton you've had. Usually that triangle is equilateral. Well, no, the bottom is not. But at least those two angled sides, those two legs, those should be the same. And we also know that it's the same because they didn't give us another measurement. They didn't put something right here saying what that length was or right there. We only have this measurement. So because that's all we have and we're being asked to solve this, we kind of have to assume that this rectangle is the same as this one, okay? Because this part's going to be 4 and this part has to be 2.8, but always double check it. So in this case, the left is the same. So I'm just going to write the 11.2. And then I need the total of this triangular prism that's showing. So I've got 4 plus 11.2 plus 11.2, and I get 26.4 inches squared. And then the last thing, why is it not writing the 2 for me? The last thing I would have to do is combine them. Okay, so 208 plus 26.4. I still have the 26.4 in my calculator, so just adding the 208, that's 219 inches squared, and that would be your total surface area. Okay, remember, if I made any mistakes in here, let me know. I just kind of did it quickly and tried to get as much in there as possible. Okay, bye friends.